All right, so in this example here, it's asking for question 6c. It says, so we've got the equation and they want us to, in part C, boats which need a depth of W meters are permitted to enter the harbor only if the depth of the water at the entrance is at least W meters for a continuous period of 1 hour. Okay. So what they're trying to say here is you've got a graph, okay? You've got a graph and it's a sine graph. So I'm expecting my equation to be something like, say if I were to draw it, it may be up by 10, amplitude of 3, so it's between up 10 and height of 3. So it'll be something like this that carries on, okay? And that's 13, whilst this is 10 and this is 7, all right? In this graph, what they want you to find, okay, so the boat can only go through when the entrance is at least W meters for a continuous period of 1 hour. Now, what you can see is that if I said 4, hypothetically say 4, not 4 meters, let's just say 8 meters, right? If it was 8 meters, you can see that once it hits 8 meters and below, okay, so at least 8 meters, what you can see here is that if that was 8 and I need at least 8, clearly this region here will not be accepted because it needs to be 8 or more. So then this region up here becomes the one that's above 8 minutes for a certain duration from here to here. What we want, okay, is for it to be above a certain value. So instead of 8, let's say W, and we want it to be a duration of 1 hour. Now, the best way to sort of calculate it is that to ensure it's going to be at the minimum, at least that point for 1 hour, okay, for continuously for 1 hour, that means at this maximum peak, we're looking for when it's 30 minutes on the right and 30 minutes on the left, because that will ensure that there will be a continuous period where it is above a certain value. See what I mean? So that's when it's above, and clearly this is when it's below a certain value. So because I want it above, well, find any maximum or minimum, and you can then find the 1 hour difference between it. So 30 minutes on each side is essentially how you would work through this problem. So if we're doing C right now, doing C, the maximum depth is clearly at 13. So we know that this is how high the entrance of the harbor can get to on any particular day. That's the depth of the water, so 13 meters. And from the graph, I haven't drawn the graph here, but essentially we got to first find when is it first, the maximum, right? So I can find the maximum going back to my CAS. Let's go back to my CAS here. We're gonna define it and we're gonna sketch it just so we can work with them. So let's try over here. So the question's there. Add a calculator. I'm gonna define f of x is equal to 10 plus 3 times sine of pi pi over 6 times x, and I want it between 0 less than or equal to x less than or equal to 24. Okay, so when I sketch this, let's do f of x. What did I just do there? Delete. Let's do it again. F of x, can't see it. Menu for A. There it is. I'm going to adjust it horizontally. So menu for 1, maximum, say 25. Now I can see the graph. Okay, and what I'm looking for is clearly at the maximum, all right, I want it at least half an hour on each side to make a duration of 1. So if I go to menu 6, menu 6 maximum, so number 3, and here we go, from left to right, that tells me when it is exactly 3 hours after midnight, then that's when it's at maximum. So based on my graph here, I can then say, all right, well, it takes, I can keep drawing this, but what I'm interested in most is the fact, I can't seem to choose. That's all right. The maximum occurs at 3. So for it to stay continuously above a certain level for 1 hour, that means this has to be 2.5, has to be 3.5, and then this distance that you have above it from here to here will then have to be for 1 hour. That's when it'll be above for 1 hour. Okay, so when the question asked me, what is it asking for? It says, find correct to the 1 decimal place the largest value of W which satisfies this condition. So we know that it will be from 2.5 to 3.5. So the first thing you need to know is, well, what is the value at 2.5? So in my graph here, if I go to f of 2.5, that gives me 12.8977, but it says correct to 1 decimal place. So really, as long as the value is 12.9, for example, and above, then it will definitely be, so if I had here 12.9, it will only be above 12.9 for 1 hour between 2.5 to 3.5, and that will guarantee that the distance is above that line for 1 hour. Okay.